simplifying radicals by reducing the radicand. So you have here square root of 50. We can write this one, break it into 25 times 2. Okay, 25 times 2 is 50. Now, this 25 is a perfect square, meaning we can take the square root of 25. So, we can write this one also, 25 here, and 2 there. So, which is better for you? This 25 times 2 or this square root of 25 times square root of 2? I think this one's better because you can separate the one that you can take the square root or cube root or fourth root, and the one that you cannot do the square root, cube root or fourth root here, especially when you have letters already. So here we take the square root of 25, which is 5. When you write the 5, you don't put the radical sign anymore, and then this times, so you have a square root of 2 here. And that's how to simplify. And then our radicand now is reduced to square root of 2 only. For square root of 80, let's do the 4 first, and then the shortcut afterwards. So we can write this one like 4, square root of 4, and then this one is 20. 4 times 20 is 80. Why 4? Because 4 is a perfect square number. So here, square root of 4 is 2. And then we have square root of 20. But the square root of 20 is not yet simplified. We can still break them and get a perfect square number from 20, which is 4 and 5. So here, we have still the 2 here, and let us break the 20 into 4 and 5. Why 4 and 5? Because 4 is a perfect square number. So we have 4 here, and then let us separate the 5 here. And then here, 2, and then the square root of 4, put a times there, is 2, and then square root of 5, and then 2 times 2 is 4, then you have square root of 5, and that is square root of 80. Okay, now if you know that this square root of 80 can be broken into square root of 16 times square root of 5, then this one is the shortcut. If you can do this one, do this one. I'm just showing you the other way of solving it, the long way and the shortcut way. So square root of 16 is 4, and then you have the square root of 5, and you have the same answer. 4 square root of 5, 4 square root of 5. Okay, we have here cube root of 81. Here, okay, is cube root. This one is base 3. So we have 3 times 3, 9 times 3, 27 times 3, so 81. So we have 2 the 4th. Now, because this one is 4, it is more than 3. So we can write this one like this. Cube root 3 to that one, and then 3 to the first, right? Same base. We add exponent 3 plus 1 is 4. Now with our concept, if we have 3 and 3 here, and this one is 3, we cancel this one, and we have this one 3, but the other one still in cube root. So we have 3. Or we can break this one cube root 81 is 27 times cube root again of 3. And the cube root of 27 is 3. Cube root of 3, which is the same as our answer there. Okay, number 4, let's have letters. So this one is square root of m squared. So perfect square, exponent of 2, 4, 6, 8. So square root of m, no, is square root of m. Square root of m squared is m. Why m? Because m times m is m squared. Square root of m to the fourth is m squared. M squared times m squared, we have the exponent m to the fourth. Here, this one is 2. This one, cancel and cancel m. That is our concept. So that is m. For here, because this one is 2, we can break this one to m2. And then the other one is m. 2 plus 1 is cubed. Now this one is 2. Of course, this one is 2. Square root. We cancel this one. So our answer here, square root of m squared is m. M times m is m squared. And then we write as this m and then the square root of m. So if we have a square root of m cubed, that is m square root of m. Okay, this one is 2 again. So here is exactly m squared. M squared times m squared is m to the fourth. Now, if you want to expand this one, because this one is 2, you're going to write here the m squared. And then here is another m squared. This one is 2, of course. They are the same. And then you cancel this one. So it's m times, cancel this one. And then you have m. And m times m is m squared. So for this one, just break this one into m to the fourth. M to the fourth, m6, m8. Okay, and the other one is simply m. 4 plus 1 is 5. And the square root of m to the fourth is m squared. And then you write square root of m. For this one, you have to write this like the one that we did here. So we have put the cube root, don't forget to write the 3. Then we'll break this one into with 3 because this one is 3. Okay. Now to complete the 5, this one is cube root is m. To complete this 5 here, we have the 3 here, so we have put the 2 there. So here, cancel the 3, so we have m here, and still we have the cube root of m is squared here, and that is this cube root of m to the 5th. Okay, number 9, we have 5th root of 32x to the 7th, y to the 5th, z. So here, let's have the terms that we can take the 5th root and the terms that we can't get the 5th root. We have the perfect 5th root. We don't have the 5th root of these terms here. So we separate them. 32. So 2, 4, 8, 16, 32. It's exactly 2 when we take this 5th root of 32. So we write the 32 here. Okay. X to the 7. We need only 5 of this. X to the 5th. The missing one we write here. To the 2nd. 5 plus 2, 7. Y to the fifth is exactly y to the fifth here. Y there? No. We have already the y to the fifth there. Z? No. So we put the z here. Then we take the fifth root of 32, which is 2. Fifth root of this one, we can cancel. So we have x here. 5 and 5. So we have y here. And copy the fifth root here of x squared z. Number 10. We have 5 times 4th root of 48, a to the 4th, b to the 5th, and c to the 6th. So for 48, we need only the 4th root. So 2, 4, 8, 16. So we get the 16 here, and the other one is 3 to make it 48. So here we have 5. Don't forget the 5 here. And here for the perfect 4th root here. And then we write the 16 here, because 4th root of 16 is 2. This one is exactly 4 and 4. So we write the 8 to the 4th here for 4. B, we need only b to the 4th. Okay. C, we need only c to the 4th. And then we still have the 4th root here. And then for 16, to get the 48, the 3 is written here. A to the 4th? No, because we have already a to the 4th only here. B to the 5th? Yes, there is one b missing. B to the 1st and b to the 4th is b to the 5th. C to the 6th, still we have c squared there. If you multiply this two, you will get this one. Equals. So let's have equals here. We have 5 times 4th root of 16 is 2. 4th root of a to the 4th is a. B to the 4th is b. C to the 4th is c. 5. And then just write that 4th root there. 4th root 3b c squared. And then finally multiply this one. Then a, b, c, and then we have 4th root of 3b c squared.